Good morning, scholars. Today we're going to be talking about translations, reflections, and rotations. You probably know these terms differently. You might know them as slide, flip, or turn. However, I do need you to become familiar with the vocabulary because sometimes different math textbooks or tests or later on in math, they won't refer to the terms as slide, flip, and turn. They'll refer to the terms as translation, reflection, and rotation. So the first thing we're going to talk about is translation, which is a slide. So the definition for a translation is a movement of a figure along a line without flipping or turning. So basically, it's like we have this letter H and we just want to slide it over without picking it up, without turning it or anything. This is a slide. Now, it doesn't just have to move in that direction. I can move it this direction, this direction, this direction, this direction. As long as I'm not changing anything and I'm staying on a line, that is a slide. And a slide, the figure stays exactly the same. All right, now I'm going to still work with this letter H, and I'm going to show you a flip. A flip is actually known as a reflection, and it's the movement of a figure over a line so that the figure faces in the opposite direction. Now remember that the line can be imaginary. So here's my flip. There you go. I didn't do that very well. Flip. There you go. Now it's interesting with this letter H because when it is flipped, it actually still looks the same. Some things don't. So I'm going to take this plug and I'm going to flip it. This is my imaginary line. I'm going to flip it. And now it looks different because the prongs are on the other side. So a flip is known as a reflection. I think about a reflection as standing, yes, looking in the mirror, but standing and looking in a body of water that's very clear where you can see your reflection. That is actually a flip if you think about it, where your body is and where the reflection is in the water. Okay, so reflection, here we go. Again, a reflection is the movement of a figure over a line so that the figure faces in the opposite direction. So our letter H still looked the same, and that would be to some lines of symmetry, but our plug looked different because the prongs were facing in the different direction. All right, so those I feel like are pretty simple. Translation is your slide, and reflection is your flip. But now we're going to move on to turns. And I think turns are kind of interesting for a number of reasons because of how they all fit together mathematically. A turn is the rotation. It's the movement of a figure around a point. And this is where it becomes interesting because I want to think about it in terms of a clock. This is going to be my imaginary point. And I'm going to move this G clockwise only for a quarter turn. Now, this is where I want to connect everything. A quarter turn on a clock, think about moving from 12 o'clock or the number 12 to the number 3. That would be a quarter turn. Now, remember when we talked about fractions and we talked about 1/4 or a quarter, we related it to time as well and said 1/4 of 60, because there's 60 minutes in an hour, would be 15. So moving this the same way as you would on a clock, 15 minutes from the 12 to the 3 would be a quarter. So I'm going to pretend that the top of this G is at 12, and I'm going to move the top of the G over to the 3. This would be my imaginary point. Bear with me. I'm trying to keep it. There we go. That would be a quarter turn. Now notice that the G looks different just by moving it a quarter. Now I would like to go back up, and I would like to do a half turn. And you know what I'm going to say? 1/2 of 60 is 30. We're going to move from the 12 to the 6 because that would represent the 30 minutes, right? And half turn. Here we go. That would be your half turn, moving from here all the way down here. Now the G looks different again. Finally, I'm going to do a 3/4 turn, which means 3/4. I'm going to start here. Here is my 12. I'm going to go past the 3, past the 6, all the way to the 9. There's my quarter turn. There's my half turn. And now here is my 3/4 turn. Notice that the G looked different every single time. One of the reasons that the G looked different is because it does not have lines of symmetry. Now, this is what I mean.